Today we are talking about 45, 30, and 60-degree angles. Now, and their trigonometric functions. To do that, we need to go back to a right triangle and recall the definitions of sines and cosines through the right triangle. So we start with 45 degrees. We're gonna have a triangle, ABC, right triangle. Angle C is 90 degrees. Angles A and B are going to be 45 degrees. Now, from geometry, we know if you have a triangle with two congruent angles, in this case, angles A and B, that triangle is going to be isosceles, which means two or three sides are going to be the same length. In our case, it's going to be AC and BC, the legs of this right triangle. Well, let's call the length of those sides as A. Okay. Then, by Pythagorean theorem, we can calculate hypotenuse and AB, and that's going to give us A square root of 2. Now, if you look at sine of angle A, and that's sine of 45 degrees, it's a ratio of opposite leg, which is BC, to hypotenuse AB, right? So, in this case, we have A divided by A squared of 2. We can cancel A and get 1 over square root of 2. Sometimes people don't like square roots in denominators. In this case, we can just multiply both numerator and denominator by square root of 2 and get square root of 2 over 2. Okay? Now, if we consider cosine of angle A, it's going to be adjacent leg AC to hypotenuse AB, but since both legs are the same, the cosine and sine of 45 degrees is going to be the same. Now, when it comes to tangent, tangent is sine over cosine. Since they're both the same, tangent is 1. Cotangent is cosine over sine. Again, they're the same. It's 1. Pretty easy. Now let's go to 30 and 60 angles. For that, we'll create, again, a right triangle with angles 60 and 30 degrees. Angle A is going to be 60, angle B is going to be 30. Okay? But now we're going to do a little bit of trickery. What we're going to do, we're going to take this triangle ABC and we're going to create a copy. We're going to clone it. Okay? And then we're going to reflect it. We're going to flip it along the side BC. And we're going to put it to the right of this triangle. And we're going to get something like this. So that BDC is a flipped triangle. It's basically the same triangle as ABC, only flipped. But now if you look at this big triangle, we got ABD, okay? All three angles of that triangle is 60 degrees. From geometry, we know that triangles with all angles 60 degrees are equilateral triangles, which means all three sides, AB, BD, and AD, are going to be the same length. Let's call it A. Okay? Now, here, if AD is A, in this case, AC is going to be half of it, right? And now, well, we know 2 out of 3 sides of the right triangle. We don't need that right triangle on the right anymore. But we can easily now calculate the side BC from Pythagorean theorem. If you do that, you get A squared of 3 over 2. And again, and after that things are pretty much, straightforward. If you look at angle A, sine of angle A, it's sine of 60 degrees. It's opposite leg to hypotenuse, BC over AB. And we get a squared of 3 over 2 divided by a, cancel a, we get square root of 3 over 2. Cosine of that angle is adjacent leg, which is AC, over BC, or hypotenuse. Again, it's a over 2 over a, and cosine is half. Okay. Now, when we want to talk about 30-degree angle, we need to look at angle B. Oh, I guess I forgot to talk about tangents. Well, tangents are easy. Tangents is sine over cosine. It gives us square root of 3. Cotangents is 1 over that, and it's 1 over square root of 3. Again, who doesn't like square roots in denominator can multiply both numerator and denominator by square root of 3 and get square root of 3 over 3. Now, when we go to angle B, 30 degrees, sine of B is, again, its opposite leg to the hypotenuse. But now, this is opposite leg for angle B. And for that angle, opposite leg is AC. So you see over AB, and we can see that sine of B is simply cosine of A, and that is a half. Cosine of B is adjacent leg, which is BC to hypotenuse AB, and that's the same as sine of angle A, and that is square root of 3 over 2. Now, tangent of 30 degrees is equals to cotangent of 60 degrees, and cotangent of 30 degrees is going to be tangent of 60 degrees. And that's it. That's pretty simple.